Hey Algebra 2, here are the notes for 14.1, day 1. I know this says Desmos graphing activity, and you can go ahead and do that. However, I'm just going to go over a quick overview of what you would see if you did that activity. So if we use Desmos to actually graph y equals sine x, and then we labeled the x and y axes, it would look something like this. We're going to start at 0, kind of like we did in our activity the other day. And we would see that as we round the unit circle, we start at 0 degrees. So 0 degrees on here. We notice until we get to 90 degrees, it's going to go up. And when it hits 90 degrees, we start to go back down in the down direction. So we're going to follow our line down. When it hits 180, it doesn't stop going down, but it does cross the x-axis. As it keeps going down, it gets to about 270 degrees. Actually, it gets to exactly 270 degrees. I'm not sure why I said about. When it hits 270 degrees, it decides to go back up. And it ends up back on the x-axis at 360 degrees. So it takes 360 degrees to go one full loop around the unit circle. We notice if we keep going, I'm going to do it in dashes here, that after another 90 degrees, or at 450 degrees, we're back up at the top of our unit circle. Back at 540 degrees, we cross the axis again. Keep going down here. We hit 630 degrees. Sorry, just trying to read my notes. And then at 720, we end up back on that axis. So you'll notice that full loops happen every 360 degrees. So that answers our question right away. It says, what is the period of the sine function? Well, it takes 360 degrees, or a full 2 pi radians, for the unit circle or the sine function to repeat itself. So how many points do you think are necessary to sketch one period of the function? Well, if we use our method from last week, we start at 0, there's 1. We go up and hit a maximum, that's 2. We're hitting a 0 at 180. We hit a minimum at 270. And we hit another 0 at 360. So those 5 points are necessary points to sketch one function, so we're going to say 5. 5 points are necessary. Now, what are the maximum and minimum values for the sine function? Well, on our unit circle, the lowest we can go is -1, and the highest we can go is +1. So the max and min values, it makes sense, would be 1 and -1. How does this relate to the unit circle? Well, the unit circle is periodic. This means it repeats itself. And I also want you to let's look at the sine curve. When is this positive? When is it above the x-axis? Well, between 0 and 180, also known as in quadrant 1 and 2. So I'm going to put that. Sine is positive in quad 1 and 2. And then sine is negative, it makes sense, if we look at our graph, or if we just look at our unit circle, between 180 and 360 degrees. It's below the axis here. It's in the negative zone of numbers between 180 and 360 degrees, and that would be in quads 3 and 4. Yes, my 3s look like my and symbols. I apologize for that. So now if we use Desmos to graph y equals cosine of x, we're going to see something very similar. Essentially what it is going to start looking like is our sine function, but shifted over. When we're at 0 degrees, our cosine is already 1. It's not 0. By the time it gets to 90, that's when it has dropped below the axis. Once it gets to 180, it has become negative. I should label these as I go. So at 90 degrees, we have a 0. At 180, we have a minimum. As we go back up to 270, we have a 0. As we hit 360, we have a maximum. So you'll see it's kind of got the same shape. It's just not quite in the same place. It's shifted over. And this is actually one full period of the of the cosine function, because now you'll notice if I keep going with this, it repeats the exact same motion at 450, at 540, kind of bottomed out there, and then at 630, and then it finally ends again at 720. So the period for this function is the exact same, it's just a little bit different placement. So it's still 360 or 2 pi radians. How many points are necessary? It's still going to be that 5, but let's just remind ourselves of why. We start at a maximum instead of starting at a 0. We then get to a 0, then to a minimum, then to another 0, and finally up to a maximum. So those 5 points are still necessary, they're just in different spots. 5 points. What are the max and min? Just like on the unit circle. It's a unit circle. It's a radius of 1. Its max is always going to be 1. Its min is always going to be -1. How does this relate to the unit circle? Well, same thing we set up here. It's periodic. But the difference is sine is going to be positive in quads 1 and 2 and negative in 3 and 4. But cosine is positive in 1 and 4. And it's negative in 2 and 3. And this makes sense because we go from talking about our x's to talking about our y's, or I guess it'd be this one in this case, it'd be from our y's to our x's. Where are our y's positive? In quads 1 and 2. Where are our x's positive? In 1 and 4. And that just makes sense with our quadrant here. This is where x is positive. I'm going to say x values. I guess I could illustrate that up here too. If we think about where our y values are positive, y values, those are going to be positive in those upper quadrants. So it makes sense for sine and cosine, which are just our x and our y values. All right, there's a ton of helpful information on the back of this. However, I am not going to really highlight anything other than this is the unit circle with the sine function. Otherwise, this just shows you a little bit about changes in amplitude. That's how tall our waves are. And then our period, you notice as the period gets shorter, our inside number gets bigger. As our number inside gets smaller, our period gets longer as well. You can take a look at that. If you have any questions on those relationships, you can come chat, but I'm not going to go over them in this video. Let me know if you have any.